Professor Belfrost's science class is back.
Hi, welcome back to my class. Today we'll continue our lesson on the prerequisites of algebra. This is the third lesson, so keep going. And today's topic about algebra is about expressions, algebraic expressions, and we will analyze the components of an algebra expression one by one. Okay, so let's start. First, a variable and a constant. So what's a variable? A variable is a letter that represents a number or quantity whose value may change. You can pick any letter to be a variable. It doesn't matter. And a constant is a number whose value always stays the same. An algebraic expression is a collection of constants and variables joined together by the algebraic operations of addition, subtraction, multiplication, and division. Maybe this is very elementary, right? And now we move to equation. What is an equation? I think all of you have heard this term before. An equation is basically just a mathematical statement indicating that two expressions are equal. And a formula, which is another form of equation, is an equation expressing a relationship between constant and the variable quantities. There are some rules of exponents, namely product rule, quotient rule, power rule, zero exponent rule, negative rule, power of product rule, and power of quotient rule of exponents, yeah, which I have explained in my last lesson, second lesson of prerequisite of algebra. I want you to check it again because today um, will be the next part of that. Okay. Then scientific notation will be used mostly to write very small and very large numbers, and then principal square root of a is the non-negative number that when multiplied by itself equals a, and it is written as a radical expression with the symbol called radical over the term called radicand. Okay, so that's all for the revision. I mean, yeah, about our short summary on the last lesson, and now let's discuss new topic, and today's topic is about polynomial. Okay, polynomial, let's go. So let's see the form I have given to you. This is another formula. For example, we have formula of 4x squared plus half x yard. So actually this formula is called a polynomial, which is a sum of a difference of terms, each consisting of variable raised to a non-negative integer power. Yeah. When a number multiplied by a variable raised to a power such as half, it is known as a coefficient of that term. Okay, so coefficients can be any numbers, can be positive, negative, or zero, and can be a whole number, decimals, or fractions, even fractions. Okay, each product, such as 5 times x to the power 4 or 67 times pi times x, is a term of polynomial. If a term doesn't contain a variable, then it's called a constant. A polynomial containing only one term, such as 10x squared, is called a monomial. A polynomial containing two terms, such as 3x squared minus 7, is called a binomial. And a polynomial containing three terms, such as minus 3x squared plus 9x minus 2, is called a trinomial. We can find the degree of a polynomial by identifying the highest power of the variable that occurs in the polynomial. The term with the highest degree is called the leading term because it is usually written first, and the coefficient of the leading term is called the leading coefficient. This is very clear, okay? When a polynomial is written so that the powers are descending, we can say that this is in the standard form, okay? Let's see what's the standard form actually. You have a leading coefficient and leading term written first, and and the n of the leading term indicates the degree of the polynomial, plus blah 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 plus x2 x squared plus x1 a1x, I mean, plus a0. A0 is the constant. Okay, easy. Now here is how to identify the degree and the leading coefficient of a polynomial expression. First, find the highest power of x to determine the degree. Maybe you need to rearrange all the terms again. Okay, Second, identify the term containing the highest power of x to find the leading term. And third, identify the coefficient of the leading term. Quick example, for minus 2t cubed plus 5t uh, to the fifth plus 7t, we can see the highest power of t is 5 and the degree is 5. Then the leading term is the term containing the degree, which is 5t to the fifth, and the leading coefficient is the coefficient of the term, which is 5. Okay. Given multiple polynomials, we can add and subtract them by combining the like terms and simplifying and writing it in standard forms. Quick example, you have given this expression to be simplified. So actually you just need to group like terms, I mean which have the same degree. So because x to the x cubed doesn't have friend, so it must be alone. But x squared it has friend, we can have 12 x squared and 8x squared to be added together. X also have two terms which is like, which is 9x and minus 5x, and the constant is minus 21 and 20 also grouped in one group. Then we can just simplify it and gives us a new expression, more simplified term 1, which is 4x cubed plus 20x squared plus 4x minus 1. So given the multiplication of two polynomials, use the distributive property to simplify the expressions. We need to multiply each term of the first polynomial by each term of the second. Yeah, actually you can just switch the which one is first, which one is the second, it is no matter. And second is combine like terms and just simplify as before. Okay, so quick example, find the product of 2x plus 1 times 3x squared minus x plus 4. So first we need to apply the distributive property as shown, then just multiply it as usual, then combine the like terms as we have done in the previous slide, then just simplify it to get the final product, which is 6x cubed plus x squared plus 7x plus 4. So to do multiplication of two binomials, sometimes we use a shortcut called a FOIL, FOIL. So it is called a FOIL because we multiply the first term, the outer term, the inner terms, and then the last term of each binomial. So the FOIL method arises out of the distributive property. We are simply multiplying each term of the first binomial by each term of the second binomial and then combining like terms. Let's see the example. Okay, so this is the general form, which is uh, ax and cx is called the first term, and b and d is called the last terms. B and cx is called the inner terms because it is inner, and outer terms, which is ax and d, because it's the first and the last one. Okay, and the product is acx squared plus adx plus bcx plus bd. It's very easy. Okay, so by applying FOIL to simplify an expression, we need to follow these 6 steps. Very easy. First is multiply the first terms of each binomial. Then second, the outer terms of the binomial. And third, inner terms of the binomials. Fourth, the last term of each binomials. Then we just need to simply add all the multiplication or the product result from 1 to 4 step. Then combine like terms and simplify. Quick example for you. By using FOIL method, we can find the product of 2x minus 18 times 3x plus 3. Just follow the step as I've mentioned before. First, find the product of the first term and it gives us 6x squared. Then find the product of the outer terms, it gives us 6x. Find the product of the inner terms and it gives us minus 54x, I mean. Then find the product of the last term and it gives us minus 54, I mean. And we are done with all the multiplication, and we just need to add this product's result, which gives us 6x squared plus 6x minus 54x minus 54, and then we combine like terms and then just need to simplify it and give us 6x squared minus 48x minus 54. Okay, so for a polynomial, there exists certain spatial forms actually for binomial products that call a perfect square trinomial, which is when a binomial is squared, the result is the first term squared added to double the product of both terms and the last term squared. It can be written as x plus a squared equals x plus a equals x squared plus 2ax plus a squared. So for example, if you want to square for x minus 1, then it yields 16x squared minus 8x plus 1. Easy, right? Given a binomial, we can square them first to square the first term, second square the last term, and the middle term We double the product of the terms, then add and simplify. Quick example for you. Please expand the expression 3x minus 8 together squared. So begin by squaring the first term and the last term, which yields 9x squared and 64. And then we just need to add the double of the product of the two terms, which is 3x and minus 8. So the double of product of 3x and minus 8, it is 2 times 3x times minus 8, which is minus 48x. 48x, I mean. Okay, so we just need to simplify it all, and it yields 9x squared minus 48x plus 64. Okay, so that's the first spatial product. And here's another spatial product, which is called the difference of square, which occurs when we multiply a binomial by another binomial with the same terms but the opposite sign. So because the sign changes in the second binomial, so it can cancel each other and left only the square of the first term minus the square of the last term. Let's see the form, which is a plus b times a minus b yields a square minus b square. For example, quick example for you, 2x plus 3 times 2x minus 3, it gives us 4x squared minus 9. So given a binomial multiplied by a binomial with the same term but the opposite sign, we can find the difference by square the first term, then square the last term, and subtract the square of the last term from the square of the first term. Example, 9x plus 4 times 9x minus 4. This is another example for you. So because we know that 9x squared is 41x squared, then square the last term 2, 4 squared give us 16. Then we just need to subtract the last square from the first square, which is 41x squared minus 16. That is the result. Now let's try working with polynomials of several variables. Actually, it is the same, but we need a patience to solve it. So multiply x plus 4 times 3x minus 2y plus 5. So to solve this, first we need to apply the distributive property, and then we multiply each term as usual. After it, we can combine the like terms and then simplify. It gives us 3x squared minus 2xy plus 17x minus 8y plus 20. Next, we will discuss about factoring a polynomials. So when factoring a polynomial expression, our first step should be to check for a GCF. So what is a GCF? So GCF is written common factor. So GCF of a variable is just the largest polynomial that divides evenly into the polynomials. For example, 4 is the GCF of 60 and 20, and 4x is the GCF of 16x and 20x squared. So given a polynomial expression, to factor out the greatest common factor, we need to follow these 5 steps. Very easy. First, identify the GCF of the coefficients. Second, the GCF of the variables. Then we just need to combine the GCF of the expressions. Then determine what the GCF needs to be multiplied by to obtain each term in the expressions. And fifth, we can just write the factor expression as the product of the GCF and the sum of terms we need to multiply by. So here is the example for you. Factor 6x cubed times y cubed plus 45x squared y squared plus 21xy. So as I have stated before, first we need to find the coefficients. So GCF of 6, 45 and 21 is 3, while GCF of x cubed x squared x is x, and the GCF of y cubed y squared and y is y. Combine these to find the GCF of the polynomial, which gives us 3xy. Then next, determine what the GCF needs to be multiplied to obtain each term of the polynomial, and we'll find that that is 6x cubed, and we can find the GCF easily, and also the complementary terms. Finally, we can write the factor expression as the product of GCF and the sum of terms we needed to multiply by, and give us as shown in the slide 3xy times in bracket 2x squared y squared plus 50xy plus 7. Easy. Okay, so for factoring a trinomial with leading coefficient 1, which is a trinomial of the form x squared plus bx plus c, it can be written in factor form as x plus p times x plus q, where pq equals c and p plus q equals b. And please note that some polynomials cannot be factored, and this trinomial is called to be prime. and then we need to follow this form. Okay, so list factors of C, then find P and Q, a pair of factor of with with a sum of B, then write the factor expression x plus P, x plus Q. Here is a quick expression. Factorize x squared plus 2x minus 15. So we have trinomial with leading coefficient 1, b 2, c minus 15. So we need to find two numbers with a product of minus 15 and a sum of 2. So here's the table that I have provided. So we need to find a pair with the desired sum. Now that we have identified P and Q as minus 3 and 5, and we can write the factor for s x minus 3 times x plus 5. Okay, so that's trinomials with leading coefficient other than 1 are slightly more complicated to factor. For these trinomials, we can factor by grouping by following 6 steps. So list factors of AC, find P and Q, rewrite the original expressions, pull out GCF of ax squared plus px, pull out the GCF of qx plus c, and factor out the GCF of the expression. Quick example for you. Factor 5x squared plus 7x minus 6 by grouping. So first we determine the AC, which is minus 30, and we then need to find two numbers with the product of minus 30 and sum of b equals 7. Here is the table. So from the table we can find the desired sum is when p equals minus 3 and q equals 10. We then need to rewrite the original expression to be 5x squared minus 3x plus 10x minus 6. Then factor out this GCF of each part, which gives us my 5x minus 3 times x plus 2. Next, we talk about factoring a perfect square trinomial. So given a perfect square trinomial, first, confirm that the first and last term are perfect square. Second, confirm that the middle term is twice the product of AB. And then we can just write the factor form. Okay, easy. So here is the quick example for you. Factor 25x squared plus 20x plus 4. So we notice that 25x squared is 5x being squared and 4 is comes from 2 being squared. Okay, so there are both perfect squares. Then the second is to check if the middle term is twice the product of 5x and 2, and it is indeed. So the trinomial is a perfect square trinomial, and it can be written as 5x plus 2 together being squared. Okay, so a difference of squares can be rewritten as two factors containing the same terms but with opposite signs, written as a squared minus b squared equals in bracket a plus b times in bracket a minus b. So given a different square, factor it into binomials by confirming that the first and last term are perfect squares and write the factor form as a plus b times a minus b. Very simple. Quick example, 9x squared minus 25 factoring. We notice that 3x being squared gives us 9x squared and 5 being squared gives us 25. So they are both perfect square. Then the polynomial can be represented as 3x plus 5 times 3x minus 5. Now take a look at a sum of cubes, which can be factored to be a plus b times a squared minus ab plus b squared for the sum, and uh, for the difference, it is just the opposite, just the conjugate. Okay, we can use the acronym SOAP to remember the signs when factoring the sum or difference of cubes. Okay, so same opposite, always positive. Okay, for example, x cubed minus 2 cubed, it gives us x minus 2 times x squared plus 2x plus 4. So for example, we need to factor x cubed plus 512. So we notice that both terms are cubes, then we can write it as x plus 8 times x squared minus 8x plus 64. An expression with fractional or negative exponent also can be factored by pulling out the GCF. Okay, for example, 2x through the quarter and 5x through the 3/4 can be factored by pulling out the x through the quarter and be rewritten as x3 quarter times 2 plus 5x to the half. Okay, now we are done with our lesson. Let's practice. First, find the difference of these polynomial expressions. So we just need to distribute the negative sign, then group like terms, and combine or simplify the expression, which yields 7x to the power 4 minus 5x cubed plus x squared plus 3x minus 1. Second problem, factor 8x cubed minus 125. Notice that 2x being a cube gives us 8x cubed and 5 in cube gives us 125 and both are cubes. So this can be written as the difference 2x minus 5 times 4x squared plus 10x plus 25. Third, factor the polynomial expressions 3x times x plus 2 to the power of minus 1/3 plus 4 times x plus 2 to the power of 2/3. So first we need to factor out the lowest value of the exponent, which is x plus 2 to the minus 1/3. Then we can just do factorization and simplify it, and it yields x plus 2 to the minus 1/3 times 7x plus 8. Fourth problem, which is the last problem. Charlotte has appointed a chairperson to lead a city beautification project. The first act is to install statues and fountains in one of the city's parks. The park is a rectangle with an area 98x squared plus 105x minus 27 meters squared as shown. So the length and width of the area are perfect factors of the area. A. Factor by grouping to find the length and width. And B. At the northwest corner of the park, the city is going to install a fountain. So the area of the base of a fountain is 9x squared minus 25. And find the area to find the length of the side of the fountain. So the answer is, uh, for the given trinomial, we find that AC is minus 2646. So we need to find two numbers with product of 2646 and sum of 105. And after working, we found that P equals 126 and Q equals minus 21. So we can rewrite it as shown. And factor out this GCF of each part and yields 14x minus 3 times 7x plus 9. Easy. B, we notice that both terms are perfect square of 3x and 5. So we can just represent it as difference of square 3x plus 5, 3x minus 5. Easy, right? I think this is the last problem. So factor the polynomial completely. 32x cubed plus 48x squared minus 162x minus 243 to the power of minus 1. So first we need to factor by a pair of terms. GCF of the first and the second term is 16x squared, whereas the GCF of the third and the fourth term is minus 81. Then we can just pull it out and factor it again and give us in bracket 60x squared minus 81 times 2x plus 3 together to the raised to the power of minus 1. Let's factor the first term, which gives us 1 over 4x plus 9, 4x minus 9, 2x plus 3. Okay, that's it. So here are exercises for you today. Please take a screenshot and do it by yourself. And here's the answer key for you to check your answer. Okay, so that's done for today. And here's a little quote for you. So Ralph Waldo Emerson once said, "We change whether we like it or not." So always be prepared whether you are in happy time or sad time, because change will be inevitable. Okay. So thanks for watching. Here's your to-do list. Subscribe, give a like, comment, and share. And my class will be on Thursday. So keep watching and be thoughtful.